Hello! In this video, we will build a Docker image with a compiled application for multiple platforms. In the previous video, we used a Python application which is interpreted. Interpreted applications are more flexible, dynamic, and the code is platform independent. But it also means that the source code must be interpreted when you execute it, so it can run slower and is less error-prone. So compiled languages are faster, but you have to compile them before execution, and the generated binary file is platform dependent. Let's switch to Golang, which is a compiled language. The example application is very simple, just a web service listening on the port 8080. When you call it, it returns hello and the URL. Our build script has to be modified too. We have to add compilation. The script is already prepared for multiple architectures. We built for Raspberry and 64-bit processors for Linux operating systems. But we cannot use the same application as for Python. We have to compile and build it for the specific platforms. This we can achieve with these two commands. We set the target architecture and the output file. The Docker container for our CI/CD pipeline remains the same. It's really flexible and simple, as we wanted. It can build and deploy any applications. But we have to modify the container for our application. I switched to Alpine Linux because it's smaller, simpler. And in this Docker file, we use two arguments. These define the target architecture, so based on their values, we copy the binary file to our image. Just to be sure, we save the values to a text file, so we can check it later or during the build time. Then we run the executable. The build script has already picked up the changes. It downloaded Alpine Linux base image for both architectures. Just to be sure, I also install Go, but it's not necessary, as we run a binary file. And here we copy the proper binary file to the work directory, based on the values of these two arguments. Finally, we merge the two images and push them to our repository. Replace the Kubernetes pods as usual. Let's check the results in Octant. The new image was downloaded and deployed. In the build info file, we can check if the correct binary was used for the image. If I run the executable manually, it runs, so the source code was properly built for the target architecture. If you need more details about the image creation for multiple architectures, please watch my previous video.